I generally don't forget.
Yeah.
Okay. So with this, we come to the end of this particular topic. Now we'll proceed further. Um, so much of calculation. How to do that also is all explained, but I don't know. Sometimes certain things happen. I didn't miss even one session also, any particular day. I don't know, somehow today only it got missed.
It's okay, ma'am. Anytime we start, we didn't miss any lectures also. I
Uh,
think they can manage.
So with this, we end this particular topic. Now we'll move ahead and then do the next topic. The next one says that informational context of business one. So from here onwards, the rest of the topics, all what we have are about statistics. So informational context of business one, summarizing and analyzing data. So we would be looking into what's the meaning of data and information, and then the tools that are used to present the data. So that is what we will be looking into. After that, we have index numbers. So for a business, um, the decisions are dependent on the information that is available. When we talk about management accounting also, the management accountant provides information to the management. Management, based on the information, will be able to take better decisions. So information is very crucial in an organization. So what is information? What is data? The collection of facts and figures is called as data. This data, when it is processed in the sense it is arranged in some organized pattern, that is maybe in rows and columns, and then some some way the processing is done, not the analysis, but some kind of an arrangement when it is made, we call that to be as information. The data is raw in the raw form. All whatever is possible when it is collected, the collection of facts and figures is called as data, but that data when it is processed is called as information. This information is later on analyzed, and this analysis will be useful for decision making. So there are certain characteristics of information. These characteristics indicate that the information that is collected is reliable. The characteristics of ideal information, of good information, is, there is an acronym here which can be used to remember. It is accurate, ACCURATE. So that's how we remember. So the first one is the data that is collected is should be accurate. See, conventionally, how was the data collected? The data was collected from the internal sources, that is all the records and registers that were maintained. So from that, it can be taken. The second source is that from the external sources, like government must have published something. So government, from the government sources, like published sources, any other external entity, some publishers when they publish, or some way other than the internal sources, if from many other external sources, if data is collected, that is from external sources. Of late, after the technology, we see that data is also collected as the data is being transmitted from one system to another system, to one device to another device through internet. When the data is transmitted through internet, then that also is collected. As you proceed further.
Excel sheet is only open. Can you open the? Yeah,
Today is some day. I don't know. Okay.
happens.
Actually, we've done with the financial context of business to internal aspects is done. That is over. Then the last class we've started with discounting and investment appraisals. That also we've finished. All the questions under that also is done. Now
Yeah.
we have the next topic, it is about informational context of business one, summarizing and analyzing the data. The rest of the topics what we have, all of them are based on statistics only. Okay, so the first topic here under this is the summarizing and analyzing data. Under that, what is data and what is information? So information is processed data. Data is in raw form. This data which is collected, if it is processed, arranged into some meaningful manner, then we can call that to be as information, data and information. After that, what are the characteristics of good information? This can be remembered as an acronym, accurate, ACCURATE, accurate. So in this context, I have started that data is collected from multiple sources. So conventionally, it was only internal source and external sources. Internal sources from the company's records and registers, data is collected. The payroll registers, then the production register, stores department register, time cards, the number of hours spent in the by the workers in the organization, then how the production was taken up, number of units produced, sold, unsold, every other detail about the affairs of the organization, which are recorded in the records, books of records. They are collected as an internal source, in data from internal sources. External sources like government sources where they publish the data, some other private organizations also when they publish that. So all that when it is captured and collected, we can call that as an external source of information. Together, that will be complete set of data. That data is properly organized, arranged. It becomes information. This information is later on analyzed. From the analysis, the interpretation is drawn and decisions can be taken. So that is little later. But right now, at this point of time, we see that what are the characteristics of information, or what characteristics, if they are there, that the information would be called as good information. So the first one says it's accurate. In this context, we have to remember that um, the conventional methods of collection of data is internal, external, but now after the technological advancements, we also see that data, when it is transmitted from one device to another device, is also captured by the producers, and that is used as crucial to understand the customers and serve the customers better. So when something is being transmitted on the internet, then the sellers are able to even capture that information. Like you must have experienced that when you search for something in the Google search or some search engine, you search that, the following few days you will be seeing advertisements relating to that particular product or that particular service. They keep popping up everywhere for the next few days. Since you've searched that, you must have experienced that. How do they know? How does the seller know that you're looking for that? So as you are typing something, as you are sharing information on the social media, the tools are so powerful, digital marketing tools are so powerful that they are able to capture such kind of information also. Such kind of data is also collected. Now, this data will help them to understand what is the expectation of the customer. Based on the expectation of the customer, then things will be taken up and they send a message stating that they are available, they have the product available with them, they are available to serve the product at some price, and then etc. other details. So in that case, we know that of late, whatever are the messages which are being circulated on the internet, half of them are fake information. We also know that. See, conventional sources, it's difficult to identify that there would be something inaccurate. But in case of um, transmitted data, there is every possibility that the data collected could be false data. It's not true data, false data. Okay. So the first attribute is the data should be accurate. The anything which is collected has to be validated for its genuinity. That is very important. You will be learning about these things when you study big data and other things in the future papers. When you study, you will be studying about that. So the data that is collected, captured from multiple sources, the data has to be validated for its genuinity, accuracy, or in simple terms, if you put it across, the data should be accurate. The information, when it is um, collected, this should be accurate. Then it is called as good information. Then the information should have complete set of data. In between, there should be no missing figures, no gaps, anything. Let's say if the data is collected or captured for a period of 10 years. So for every year, continuously, there should be some values there. In between year 6, there is no data available. So in that case, proper analysis cannot be taken up. So the data which is collected, the information that is collected should be complete. Then when information is collected, normally we see that that's free of cost. Collection of information, collection of data, collection of information. 1 second. So information is free of cost. Okay, it can be collected easily. But let's say if there is some cost which is paid for the information, the benefit which they derive out of that information, okay, um, that benefit should be exceeding the cost which they have spent to acquire this information. Okay, that is that it should be cost effective. Any benefit which they derive out of the information should always exceed the cost which they have spent to acquire this information. Okay. Next one is understandable. The information should be easy to understand. It cannot be in some values which the users cannot understand. It should be understandable. Okay. Then we see relevant for the purpose for which they are using that information. It should be relevant to the nature of business. It should be relevant for the purpose of analysis. So then it is good information. Okay. Then we have it as authoritative. Um, Authoritative. Then we see, let me talk about this one a little later. It should be timely. See, whenever they want it at during that particular time period, within that time period, this should be available. So that is timely. And E is easy to use. Adaptability, easy to use. Okay. The data that is collected can be easily processed and used. Okay. Highlighted. I will talk about it later. I'm not able to recollect this authoritative. Now the data can be viewed as the as at the base of hierarchy. See, once the data is processed into information, so data will be processed into information. Out of this information is processed data in context. So then the data gets converted into information. It is simple arrangement of data. Processing is not lot of work is done, but which is collected in the raw form. All the facts and figures, when they are classified or clusters, some format into which when they make the arrangements, then in that case, we call that as information, processed information. From the information, knowledge can be drawn. Knowledge using information to achieve objectives. So from this, knowledge can be drawn. Data gets transformed or processed into information. From the information, some knowledge can be extracted. Knowledge using information to achieve objectives. And then using knowledge for long-term results, that would be called as wisdom. So this is the hierarchy of data information until wisdom. How is data presented? Now, data is presented in various ways. The data can be the data can be presented on a graph. Graphical presentation could be there. Okay. Then we see there are histograms, line graphs, line charts, bar charts, multiple bar charts, or gives all these are the tools. So first one we have the scatter diagram. So when the data is processed, they are arranged. Arrangement could happen as they are common. The data which is common in nature can be grouped together. So when they are grouped together, we call that as clustering. Okay. Then if they are arranged in rows and columns, we call that as classification. Okay. So the data in its best format, either it can be made into clusters or it can be classified. Then there can be a relationship which can be established between the variables. So the variables that are collected, these variables have to be analyzed in terms of whether there is any kind of a relationship which exists between these variables. So is there any association? Is there any relationship between them should be understood. Then this so the variables can be understood in terms of whether there is any relationship between them. For example, we have in the initial days learned about the relationship between price and supply, price and demand, demand and supply. See, let's say the data is collected about multiple variables. So, is there any kind of a relationship which exists between the variables? Is what is one part of analyzing the data. So is there any kind of a relationship association between that? So are they related or not is one thing. If they are related, what kind of a relationship exists between them is another thing. So that is one part of analysis. The data could be studied for its trend. So when the data is studied for the trend, so it is presented on a graph. That's what is about scatter diagram. The data is plotted on the graph, and then based on the movement of the data, the scatter plot or scatter diagram can be drawn. So there may not be a perfect pattern which exists, but from the data points which are plotted on the graph, there could be a trend which can be understood. Trend, pattern, this has to be understood. See, why is data analyzed? Data is analyzed so that some interpretation can be drawn, some conclusion can be drawn. This conclusion will be helpful so that in future, depending on that, depending on such situations, this kind of information or this kind of analysis can be provided so that there can be an impact um, on the people who are taking decisions. The senior management is usually involved in decision making. So the top management takes decisions based on the analysis that is provided. So to analyze the data, the trend of the data, the pattern of the data has to be understood. To know the pattern of the data, one way is to plot the data on the graph. When the data is plotted on the graph, the movement of the data is observed, and there is a scatter plot or scatter diagram which is um, fitted. They fit a scatter line or a diagram. If you have a set of pairs of values denoted by x and y, so it's take set of two and then plot them on the graph. So there might be some pattern which is exhibited. So based on the pattern, here also the data points are like this. So covering most of them, there is a line which is fitted here. So that indicates that what is the trend of the data. Okay. Then this is also exhibiting that the two variables, variable x on the x-axis and variable y on the y-axis, they act in a particular manner. Okay, the scattergram, it may show that x and y have a linear relationship. Linear relationship is exhibited by an equation called as y is equal to a plus bx. So with the help of linear equation, the future values can be forecasted. That's the purpose of fitting a linear equation or linear graph. We will be learning this part also in the last chapter, forecasting. So there we will be using that. So to understand whether there is any kind of a relationship which exists between two variables, if they do, you can sketch the in a line that follows the slope. A is a slope and B is the intercept. So we will be talking about this part of it in the last chapter. Then follows the slope of the points and has a rough balance of points above and below. So covering most of them, it may not be a perfect line which touches all of them, but covering most of the points. If a line is fitted, then we call that to be as a scatter diagram. Okay, called a line of best fit. For any value of x, you can read off from the line the corresponding value of y, which gives the estimate of y. So the linear equation is given as y is equal to a plus bx. A is the intercept and b is the slope. A scattergram will show curved as well as linear relationships. There's one more thing, not only about the trend or the pattern of the data is found out, but it also helps us to understand what kind of a relationship exists between the variables. First thing, are they correlated or not also can be found out. So it is calculated by way of a variable r. R indicates the coefficient of correlation. So the coefficient of correlation lies anywhere between -1 and +1. So we see that as one variable changes, along with that, if they are associated, the other variable also changes. See, it could be changing in a negative manner, it could be changing in a positive manner. See, we see that if one variable is increasing on x-axis, the other variable on the y-axis also simultaneously increasing. So this is called as perfect positive linear. Then we have perfect negative linear. One variable is increasing on the x-axis, on the y-axis it is decreasing. So that is in a negative manner. Law of demand says so. See, when the demand increases, the price decreases, or the price increases, the demand decreases. We have understood that. So this is perfect negative linear. It may not be exactly in this manner, but it could exhibit a trend of that. So this is upward rising. So we can see that, but there are data points which are away from the line. So then most of them are in a line, but some of them could be, the data points could be far away from that. Okay. Then we call that to be as high positive, then moderate negative. Uh, uh, then here, when there is no particular pattern, See, one is rising, one is falling. There's no particular pattern as such here which we can see. When such a thing is there, we call that to be as no correlation present. Okay, they are not correlated at all. Okay, there are variables we do not see that there will be any impact on that, right? See, if there is an investor who's investing into stock market, see the ups and downs of investment, ups and downs in the stock market will have an impact on his profitability. But let's say there is a street vendor, the ups and downs in the stock market may not be affecting the profitability of a local vendor. So there are variables which are connected, there are variables which are not connected, correlated at all. So there is a possibility that there is no correlation between variables. All of them may not be related. Some of them are absolutely not connected, not related. So there is no correlation. Okay. Then we see that if they are correlated and perfectly correlated, we see there is a straight line. Like here, positive, perfect, perfect, positive, linear, perfect, negative, linear. But there could be a trend, but it is not a straight line, it could be a curve. So it is non-linear. If it is linear, it is always a straight line. It could be they are related, but they may not be in a linear format. So we call it as non-linear or curvilinear. The data, when it is presented as bar diagrams, so it looks like this. We will also be touching upon that. A histogram is the best method of displaying a group of continuous frequency distribution. The horizontal axis shows the intervals of distribution, and the chart is made up of a series of adjacent bars on those intervals as their basis. So we see that this is class interval, maybe 0, 10, 20, or 0, 100, 200, whatever is that. See, for these class intervals, whatever is the value of the variable y is raised in the form of a bar. Okay, we call this as bar diagram or histogram. Calculating the height of bars. If the intervals are of equal width, the height of bar equals the frequency of the intervals. Here, these are all equal intervals, but the last one is not equal. Okay? The class width is little wider here. If the intervals are of unequal width, the areas of the bar equals the frequency of intervals and the height of the frequency density. But this is outside the scope of the syllabus, so let's not get into that part of it. Then we see bar charts. Bars are bars of equal width have heights which represent quality. So the we see they are of equal class intervals. The size or the width of the class interval is uniformly the same. Quantities will be shown either vertical via vertical axis or by shading and a key. The horizontal axis is used only to provide a level base. So this could also be on the on a horizontal note, something like this. Like this also it can be used. Gaps are generally left between bars. In case of histogram, we don't have any kind of gap between the bars because the class intervals are adjacent, so we don't leave anything in between. But these here are uniformly the same. In each category, there is just one value to be illustrated. Okay. Then we can also have, see, for one particular variable on the x-axis, multiple things can be shown. So we call that as multiple bar chart. In each category, there are 2 or more values to be illustrated. These are shown as adjacent bars with a gap separating them from those of the next category. Interpretation. The simple bar chart shows where one particular company is making sales. The multiple bar chart does this for both companies. So here in this example, the example for one particular country. These are countries here on the x-axis. For one particular country, we see what is the performance of company one, which is in dark color, and company two, which is plain black, plain bar. So likewise, for multiple countries, multiple companies or multiple variables can be shown using a multiple bar chart. See, ogives or ogives, I don't know how it is pronounced. The way we pronounce it's fine. The dictionary says it's ogives or ogives, I think. The way we pronounce it, it's okay, fine. An ogive is a graph of a cumulative frequency distribution. The horizontal axis shows the interval. These are the class intervals. The vertical axis shows cumulative frequency. Then CF starts at 0, cumulative frequency starts at 0 at the very lowest limit and ends at the total frequency for the uppermost limit. See, the cumulative frequency is plotted. So that is a guide. We will, I don't know what type of questions are included in the question bank. Based on that, I will take it up and then work it out. The next topic is index numbers. After index numbers, so this is what we have discussed just now. Of course, we didn't do the questions. We will still have to do the questions. Then index numbers. Then we have another two chapters. The classes are extended till the class are scheduled till 21st, isn't it? I'm assuming we should be able to finish it by mid of next week. As soon as we wind it up, we'll end the sessions. We will close the sessions also. Um, um, if we are to discuss the questions from this. So let's take up the theoretical questions, numerical questions. I will make you do tomorrow's class, or not tomorrow, Monday. No. Monday's date will be what? Today's 10, 11. The next question. I hope you are able to see the questions here. Which of the following graphs would best be used to illustrate the two variables are uncorrelated? They are not correlated at all. So, which one do you think is the best one which can explain that? A bar chart, if there is, see, for that particular variable on the x-axis, we raise the bar. So that is bar. So there is some relationship. Pie chart, the pie chart is the total division of the entire resources among multiple aspects. So that is a pie chart. Line graph, see, it is presented in a line. So that could be upward, rising, downwards, going down, etc. Whatever is the manner. So that is what is a line chart. Scatter plot is the variables are plotted on the graph. They may not be in a perfect pattern, but covering most of them, there is a good fit, which is, I mean, good. There's a line which is considered as a good fit, and then that is um, presented there. So here in this case, they are not perfectly correlated, but they still manage to fit the good fit. In that case, that is a scatter graph. 157 says the following table shows that the typical salary of part qualified accountants in 5 different regions in a country, areas and typical salaries are given. Which diagram would be the best one to draw to highlight the differences between areas? Is it a pie diagram? Multiple bar diagram? A percentage component bar chart? A simple bar chart? A simple bar chart, because see, on the x-axis we would have the areas, the regions, and the typical salary for that. So just raise that and then show it. A simple bar chart. A scatter graph is being produced to show the cost of advertising and sales revenue for a business. Which values would be shown on which axis? A scatter graph is being produced to show the cost of advertising and sales revenues for a business. Cost of advertising should be on the x-axis and revenue should be on the y-axis, isn't it? Both of them cannot be on the same axis. See, as the advertisement cost increases, the sales increases. So if we take the cost to be on the x-axis, then the revenue can be taken on the y-axis. So as the cost keeps increasing, maybe it's not in a perfect linear format, but we see that the sales which is there on the y-axis also increases along with that. So as the cost increases, sales increases. Okay. Then XYZ produces 3 main products, which would be the most appropriate chart or diagram for showing total revenue analyzed into product revenue month by month. There are 3 products. Which one? So when there are 3 products, it would be which would be the most appropriate chart or the diagram showing the total revenue. The total revenue should be taken as so let's say this is product 1, then product 2, then product 3. In this case, if there is a bar chart raised, but then again they want it month by month. So each bar, whatever is raised, can have subsections like this. So that is component bar chart. So like this, when divisions are made, so each month what is the performance can be looked into. So that is a component bar chart. Line graph talks only about one variable. Pie chart is the division of the total or allocation of the total into various components. So here the answer is component bar chart. Cumulative frequencies in an ogive are plotted against the midpoint, the lower class boundaries, the upper class boundaries, any of the above. No, it's not any of the above. So it is the we'll do one thing. We'll do one question, because how do they touch? Actually, ogives are when we raise the histogram and connecting the corners of the histogram, the ogives are connected. See, we see that the cumulative frequencies are see, the cumulative frequencies are raised, but how are they raised? I mean, when there is a bar chart raised, see, they touch the upper value. I think maybe we should be looking at one question clearly. Maybe the study text may be having. So we will look into that, and then I'll explain this tomorrow. Maybe we can wind it up here. The remaining questions can be done in tomorrow's class. Okay, tomorrow is that is next class Monday.
Yeah, Monday.
So Monday's class we can take it up and then do the other questions. One set of calculation is index numbers, the other set of calculation is forecasting techniques. So with that, we would be winding it up. Maybe I'm assuming by Wednesday, we should be able to finish it. We've done it at great leisure, covering all the questions. So, but Monday, I think Wednesday, we would be able to finish it. Or if required, maybe one more day will take. I don't think it will take anything beyond that, but let's see as the days go by. We have stopped on a note of inaccurate. I'm still not convinced with this A. I don't remember. It should be accurate, it should be complete, it should be cost effective, it should be understandable, relevant to the nature of the business. E says it is authoritative. Authoritative, maybe it is about making it reliable, validating. See, the data that is collected should be validated by someone for its genuinity. Then only that will be reliable. That becomes reliable. Okay, so that is authoritative. Then timely, within that time period of that stipulated time period, it should be provided. Then it can serve the purpose. So that is timely. See, if information is required now, if it is provided after a period of time, then it may not be useful at all. Therefore, it should be timely, relevant to the nature of the business. The information that is collected should be authoritative, or it should be validated for being genuine, and the data should be easy to use. Okay. We'll continue tomorrow.
Yes, ma'am.
So many times I'm saying tomorrow, Monday. Last week also, there's another class in the evening. I told them we'll meet on Monday. So they didn't come on Saturday. That was another confusion. Okay then.
Okay, ma'am.